Every flying machine starts with one moment, the first time it lifts off the ground. But for a custom built drone, that moment isn't just about flying, it's about proving that every wire, every motor, and every line of code finally works together. Today, we're breaking down what really happens during the first custom built drone flight, the preparation, the testing, and the science that makes it possible. This isn't just flying, it's controlled engineering in action. Let's get started. A custom built drone isn't one single device, it's a system of interconnected parts. Four motors generate lift, each controlled by ESC or electronic speed control. The brain, called the flight controller, constantly measures motion using gyroscopes and accelerometers. The sensors detect every tiny movement. If the drone tilts even slightly, the flight controller instantly adjusts motor speeds to keep it balanced. In a ready-made drone, all this pre-calibrated, but in a custom-built one, you have to make sure every part communicates perfectly before takeoff. Before flying, builders spend hours on calibration because one small mistake can end the flight before it starts. Each motor spins in a specific direction or reserved while and the drone flips immediately. That's motor direction check. ESC calibration. The ESC calibration must interpret throttle signals equally so all motor speed up at the same time. Gyro and accelerometer calibration. This sensor define what level means for the drone. If they're off, the flight control will constantly fight imaginary tilts, propeller orientation. Each propeller's curve determines how it punches air. Mixing them up means instability. Only when all four systems respond correctly is the drone ready for its very first liftoff. The first flight is short, just a few seconds off the ground, but it's the most important step in testing the drone's stability and responsiveness. The pilot gently increases throttle until the drone lifts a few centimeters. This is called a hover test. During this stage, the builder checks for vibration, drift, and motor sync. Behind this balance is a control system called PIDE, proportional, integral, and derivative. It constantly measures how far the drone is from its target position and adjusts motor power to correct it. Too much correction and it shakes too little and it drifts. The goal is harmony, smooth, responsive flight. The first flight almost never goes perfectly. Sometimes motor overheats, sometimes the drone vibrates because of unbalanced propeller, sometimes it drifts because of a small sensor error. Each problem tells the builder something. A vibration might mean a loose arm, stability would mean incorrect PID values. Bit by bit, the drone becomes more stable, more precise. After landing, data from the flight control is analyzed. Motor speeds, gyro readings, and battery voltage. The builder checks for overheating, weak signals, or unexpected vibration. This data helps tune future flights, making the door safer and more efficient. That's how every professional UAV, from hobby drones to industrial ones, is refined through small, careful steps. The physics of flight is simple but precise. Each propeller creates thrust and upward force. Gravity pulls down, and the flight control continuously balances the to forces using real-time data. This is what makes drones so stable. It's not magic. It's thousands of calculations per second. So that's the story behind the first custom built drone flight. Not just about flying, but about science, calibration, and control. Every successful flight is proof of precise engineering. If you enjoyed this exploration, hit like, subscribe, and stay tuned for more deep dives into robotics and tech project right here on Zakaria Robotic channel. Bye.